Okay, welcome to part 3 of this lesson. The last part. So here it says consider angle UTV with vertex located on circle C. Line VW is drawn tangent to circle C at point T. So we've got a tangent line and a diameter. They want us to find and determine arc UXT and UYT. How would we be able to determine that? What do you think? Well, we remember that those arcs are called semicircles. Remember that this diameter is cutting this circle in half. And so we know that these arcs are semicircles. And so what do semicircles measure? How many degrees? If it's half of a circle, remember that halfway around a circle, it measures 360. So what's half of 360? That's correct. Very good. 180 degrees. So go ahead and type what I just said in your own words. You can go ahead and pause this video. So the measures of these two arcs, UXT and UYT, they both measure 180 degrees. All right. Let's go ahead and move on to question 2. It tells us to determine now these angles. Angle UTV and UTW. So what would be the measures of those angles? So we would have to go back to our picture. So they're asking for, let me go ahead and take a screenshot so I can highlight the angles it's talking about. Okay, so first of all, we just said that this arc, okay, measures 180 degrees because it's halfway around the circle, right? That's a really big little thing. There's a little dot there I'm trying to do, okay, to represent degrees. And then this arc over here measures also 180 degrees. And they're asking for these angles right here, this angle and this angle. Let's do it as red so you can see the difference, okay? So they want us to find out the measure of those two red and yellow angles. Well, let's see. These are inscribed angles because the angle, the vertex, as you can see, is on the circle, right? Even though one side of the angle is outside of the circle, it's still considered an inscribed angle because the vertex is on the circle, okay? Remember, the vertex is this point right there of each angle, okay? That's the vertex. So these are inscribed angles, and remember the inscribed angles are half of its intercepted arc. And you can see that the intercepted arcs are those blue and green arcs. And so what's half of 180? If you said 90, that is correct. So both of these angles would be 90 degrees. Okay, so go ahead and type that information in. That's what they want. They want you to say or to explain that, what we just talked about. So go ahead and pause the video and explain how we got to those angles being both 90 degrees. Okay, let's go on to number 3. It says, it appears that when a line is drawn tangent to a circle, the angles formed at the point of tangency are right triangles, and therefore the radius drawn to the point of tangency is perpendicular to the tangent line. So here's something that someone had to prove. Here we have a tangent line as the picture drawn. We have a radius from point C to A. I'm going to go ahead and highlight this information for you all as well, because I feel like for all of those who are visual learners, they need to know what angle I'm talking about, what I'm referring to. So it says it appears that when a line is drawn tangent to a circle, and this is the tangent line. I just highlighted tangent line. When it's tangent to the circle, okay, the angles formed at that point of tangency. Remember, the point of tangency is this point A. That's the point of tangency, okay? that forms a right triangle. So if you guys can see here, it's forming a triangle, and it's specifically called a right triangle. And in this picture, this is a mistake. It looks like they put the box on the wrong side, but the box should be right here. That's where the 90-degree angle is, okay? And if you have two radii, so this is a radius and another radius. If you draw two radii, you form a right triangle, okay? This observation can be proved and stated as a theorem. The proof of this theorem is done by contradiction. So recall that a proof by contradiction begins with an assumption, and using the assumption and its implications, we arrive at a contradiction. When this happens, the proof is complete. So we can actually prove something by contradicting it, okay? So lines segment CA is a radius of circle C, which we already talked about. Point A is the point at which the radius intersects the tangent line. Okay, and moving along here, step 1, our assumption, we always start with the assumption. We can say that the tangent line is not perpendicular to the radius CA of the circle. So notice that our assumption is backwards of what we said. We said that that the tangent line was at 90 degrees to the circle, but what if we assume that it is not? Then step 2, we can say that point B, another point on the tangent line, is the point at which CB is perpendicular to the tangent line, and that's why they put a little box there. Because let's say instead of where I told you the box would be with that point A, that instead it's over there at point B. So they said in step 3, consider the right triangle CBA with hypotenuse CA and leg CB so that CA is greater than CB. So I'm going to take another screenshot and highlight what we're talking about. And the whole purpose of this, if this is really confusing, I just want you to understand, even if you don't fully understand what we're doing, please understand that what a mathematician is someone who looks at a picture or a situation and analyzes it and tries to prove something and come up with a rule. And so this whole process that we're going through right now is just to show you where the rules are coming from. It's not just arbitrary, somebody said, hey, this is going to be true. They actually go through a process to figure out these rules that we teach you. And so in step 3, they said consider right triangle CBA. So let me highlight the triangle. This triangle right here, they're saying to consider it with hypotenuse CA. So we're going to say, if I was to redraw this, they're saying, hey, let's consider this triangle, and let's say that the hypotenuse is this line right there. So they're saying, let's consider this to be the hypotenuse. That means that they're trying to say that this is your right triangle, right angle, I mean. And the legs are CB, and the leg, remember, the hypotenuse is the longest line of the side of a triangle, and then CB would just be one of the legs, which is the shorter sides of the triangle. So that means that the hypotenuse has to be longer. So that's why it says CA is greater than CB. Okay, so that makes sense because we know that in a triangle, the hypotenuse has to be the longest side. Step 4 says that that's impossible because CB is greater than CA because CB equals the length of the radius. Okay? CD plus DB. So we actually just contradicted it. This is impossible. It can't be bigger because they're both radii. Okay? Notice as we look at this picture, you could easily notice that they're both radii. Okay? And actually, so let me go back here. I said this incorrectly. CA is the radius of the circle, and only from C to D, you notice where my blue line stops is a radius. But there's that small little pinch of space between D and B, right? Hopefully you guys can tell that there's a small little space here in red that I just highlighted. Tiny little space, which proves that actually the blue line is bigger than the yellow line. And so therefore the blue line has to be the hypotenuse. And so therefore that right angle cannot be there. It has to be on the side where I told you it needed to be earlier. So this right angle has to be there instead because the blue side has to be longer. So we have just proven that that's wrong. And so the assumption is incorrect. Type in incorrect. Therefore, the tangent line is perpendicular. Remember, perpendicular means 90 degrees to the radius CA of the circle. This completes the proof of the tangent to a circle theorem. Okay? So all of this is just to show you guys where these rules are coming from. It's not just arbitrary, someone just decided, okay? So let's go on to question 4. It says, it appears that when a line is drawn tangent to a circle, the angles formed at the point of tangency are right triangles, and therefore the radius drawn to the point of tangency is perpendicular to the tangent line. This is just stating what we just learned, okay? This observation is stated as a theorem, and so the tangent of a circle theorem states that a line drawn tangent to a circle is perpendicular to a radius of the circle drawn to the point of tangency. All right, number 5. Molly is standing at the top of Mount Everest, which has an elevation of 29,029 feet. Her eyes are 5 feet above ground level. The radius of Earth is approximately 3,960 miles. How far can Molly see the horizon? So I just want you in this question, even if you cannot come up with the solution or the answer, I just want you to kind of be able to let's not necessarily solve the problem here. All we want to do here is to, let's take a screenshot, is to analyze if we can see how the theorem we just learned applies. Okay, so we're not necessarily going to solve this problem. Let's just see if we can recognize the pieces that we just learned. So Molly's standing at the top of Mount Everest, okay? So that M, which has an elevation of 29,029 feet. Her eyes are 5 feet above ground level. The radius of Earth is approximately 39,000. So let's just fill in where everything, all the pieces are. So the radius is the point from the center to the side. That's the radius. And we're going to go ahead and type in, not type in, but we're going to write that it's 3,960 miles of a distance. And that means that this part is also that distance, right? Because that's also a radius. And so we're just going to say that's the same thing, 3,960. But now the mountain is, how long is this mountain right here? The mountain, or how high, would be 29,029, let me write that better, and 29 feet. Okay? And this was miles. It's very important that you notice that they're different units. One is miles, one is feet. Okay? And it says her eyes are 5 feet above ground level. That means that even above 29,000 feet, she's standing up here at the top of the mountain. So we would have to add 5 feet to that distance. Okay, and let's figure out the total distance. The total distance is what? 29,000. And I'm going to get my calculator here. So we're going to add 29,029 feet plus 5. And so the total here would be 29,034 feet. Okay? And I want to, last thing here, let's recognize that this yellow part is the tangent. We have a tangent. Okay? So, I just want you to be able to notice this information, and here we would have to use, it says, how far can Molly see on the horizon? They're asking for, they want to know the length of the tangent line. Okay? They want to know the length of the tangent line. So here's your challenge. You would have to use the Pythagorean theorem, I believe. So you would have one leg of one side of the triangle. We've got the one leg of another side of the triangle. And this is a right triangle. Remember, this would be a 90-degree angle right there. That's what we just proved. And you would have to find... So actually, they gave you the hypotenuse, which is 29,034 feet. And they gave you one of the legs, which is 3,960 miles. And you have to find how far the yellow line is. That would be your x. Now, here's your challenge. One of the units is in miles, the other one is in feet, okay? So if you want to figure this out, you can go ahead and challenge yourself. Once you find your answer, let me know and we'll see, okay? Good job. So go ahead and upload this. And our last question here is, when you are able to see past buildings and hills or mountains, when you can look all the way to the horizon, how far is that? Okay? You can use the Pythagorean theorem to help you tell. Imagine you are standing on the surface of the earth and you have a height of h. The distance to the horizon is given by d in the diagram shown, and r is the radius of earth. So this is kind of just literally what we just talked about, okay? And I told you, yes, you would have to use the Pythagorean theorem to figure this out, okay? So using your height, create a formula you can use to determine how far the horizon is. So let's take a screenshot and let's do this together. I'm going to click done and done. And like I said here, all we're worried about in this problem is using the Pythagorean theorem. So instead of using a rule, we're not going to use a rule. Let's actually apply this with numbers, and you can come up with your own numbers. So let's just recognize that this is a 90-degree angle right there, okay? If this was, let's see, this was, what numbers? Let's use easy numbers. I'm just going to be nice. And they want to find this part right there. So they say that this is 5 units on one side, 3 units on the other side, and what's the length of the other side. So remember, if you have a triangle like this, remember that it's a right triangle. And you can use, like they said here, we can use the Pythagorean theorem to answer it, okay? So I'm going to apply the Pythagorean theorem, a squared plus b squared equals c squared. And remember, your c has to be the longest side, that hypotenuse, which is right across from the 90-degree angle. So this is going to be 5 squared. And the other ones doesn't really matter. I'm going to say that one's 3 squared, and I'm going to be looking for b squared. I'm going to change it to x squared just so that maybe we're used to the x, solving for x, right? 3 times 3 is 9, x squared. 5 times 5 is 25. Remember, when we're trying to solve for x, we want to subtract, we want to get x by itself. So we're going to subtract 9 from both sides, and we end up with x squared equals, and everybody knows I don't do so well doing math in my brain, so I'm going to go 25 minus 9. In my calculator, I'm going to get 16. And you guys remember how to get rid of the x squared? All right, if you guys remember, we have to square root both sides, and then we get x by itself, and my answer is 4. So here is my answer. So remember, whenever you're given a tangent and a radius, make sure you, and if they give you a triangle, remember it's a right triangle, and you can use the Pythagorean theorem if you're looking for a missing side length. So go ahead and upload that picture, and we are done for this.